to make sure you initial and pick up a handout. The handout today is one of the tough calculations that you will need to master at this level for this chapter. And the sections I'm writing on the board have to do with, we want to know the definitions, that way we can relate the definitions with certain formulas. So I will just write down here ionic and covalent. And this is the transfer of electrons. And this is the sharing of electrons. An example is water. Or we say H2O. An example would be sodium chloride, table salt. So then we go to empirical formula and molecular formula. And our definition there is the short, it's in milli, we want to convert it in grams because we know the relationship of the molar mass of ibuprofen in grams per mole, right, to be 206.27 grams per mole. See that? And so if you have, so the first thing when you're asked, you see milligrams and then molecules, you will always want to calculate the molar mass because the units are in grams per mole, and you know that moles and molecules or atoms always has that relationship. So now, since you're given 200 milligrams, so you write down the given first, and then you want to eliminate the milligrams, to keep the grams, so that you can cancel the grams, and then all you have will just be moles, and then you multiply it by 6.02 times 10 to the 23rd. Do your dimensional analysis, do that, cancel all the units until you come up with molecules, right? So clear, very nice. And you'll know that's why I went ahead and gave you a specific copy so that you will remember these two relationships, mass percent and being able to calculate, not necessarily molecules, but being able to calculate the moles from the gram. So I just kind of gave you another to go a little further. So most of the time you'll see problems, in fact, converting moles to grams or grams to moles, because that's how we do and collect data. Okay? So chemists, we don't worry too much about the number of molecules. So any other questions on the...
I just don't get what...
which one don't you get?
The relationship they use.
Pardon, the relationship?
Yes.
Okay, because it's like the relationship that is used as far as Avogadro's number, or what? What relationship?
No, when...
Can someone help? Because maybe I'm not...
The question you asked, you can use it as a formula to get our molecule to molecule.
Okay, when you're looking for molecules.
Yes, when you ask
It can be atoms also, it can be ions.
It could be iron.
Yeah,
you can use it with the avocado.
yeah. So that was in the definition in chapter 2. Thank you. Okay, shall I do my other trick? That was fast food. Okay, I was at slide 54. Okay, and then I need to go to this one. So we have learned how to find the empirical formula, how to calculate the formula mass, the molar mass, the molecular weight, the mass percent, and our other big topic to learn today is being able to write balanced reactions. So if we have methane gas, so how many of you have walked down the Everglades, right, or where it's marshy or swampy, and there's a kind of smell that that's methane gas. But just, no, I better not digress. I wanted to tell you a story about methane hydrates that are in the ocean, right? That's really should really be the culprit for our global warming, because it's the one that will explode, right? And throw just not even volcanic eruptions or earthquakes will even compete with methane hydrates in our ocean floor. Yeah.
Like when you're balancing the equation, there's like, and on one side you have like a gas and a gas. When you have your reactants, how do you know? Like it says right there, H2O, it's a gas. How do you know if it's going to be a gas or a liquid? Good question.
What would be the best way to answer that, you think?
They'll tell you in the formula. You know, in this and this a gas.
Yeah, cause like in my last class, like they didn't tell you, like you had to know from the product that
you
had.
assume it's what's it normally? What's water normally?
I know it's a liquid normally.
Yeah.
Okay, so that's what you gotta assume.
That's why we learned the states of matter first, right? And we didn't want to cover plasma because we don't work with plasma in the lab. And so we always, in the chemical formula, they will always state whether it's a gas for G, S for solid, or L for liquid.
Well, like I'm saying, like they tell you. I know they tell you like the product. So like how do you know after they gone through their chemical reaction if it's gonna be a liquid or a gas on the other side?
How can you tell? So if this is gaseous, it will tend to be
Gaseous?
gas, yeah, also. Because then you notice that this is a gas, it's a vapor, not liquid, right? Because everything is being conducted in the gaseous state. So we'll take a quick look, right? So since mass is always conserved, so the number of atoms on the reactant side and on the product side should always be the same, equal number of atoms on both sides. These are called the reactant, the starting material, and these are called the product, the finished material, right? So organic compounds, we normally have carbon, oxygen, nitrogen, phosphorus, sulfur, very, very common ones. The structural formula for methane, or the space filling model, and I actually made a ball and stick model also, right? So that's the ball and stick model of methane. And then when we have two bonds, just like, what was the one? Who was the one where I had ethene? Did anyone? So ethene would be.
This one?
Yeah.
Oh, yeah.
How do you get back here?
You can pass it around. I'll make another one. So ethene, right? So there are two double bonds. So it's C2H4, and then you can also have three double bonds. So I'll make another one like that. So when I come and help you. Who wants to come and help me? What
What are we doing?
Oh, I'm gonna make, so we have ethene over there, right? You see that, the double bond? And then I'm gonna make this, who likes to weld, or who knows how to weld? Anybody? Nobody. You know what welding is? You've welded before, right? What's the gas that we used to weld?
I've done oxygen welding.
Or, so this is acetylene. This is the gas we used to weld with. So carbon is really unique, and that's why it's studied by a lot of compounds. So this is actually the acetylene gas, right? And here's the double bond. So carbon can form single bonds like methane, or double bonds, or triple bonds. And you'll find that the one with a triple bond is actually ends up being shorter. Okay. I know, it's way past our bedtime. I slept up now. So that's not as exciting. And so here's the gas that we use in our grill, and here's our vinegar, and all these other ones we'll just pass for now. But these are the different types of structural formulas. So not only can you actually make straight chains, right? You can make the octane in our fuel will have eight carbons. But then it can also make rings, right? Because when you have all this stretched out like that, with certain combinations, you could form instead of hexane, you could form a cyclohexane. So carbon bonding is really cool. And what do we call these compounds, organic compounds? We refer to them as hydrocarbons because it is hydrogen and oxygen. Okay, some common ones can be found in gasoline, propane gas, and natural gas. And so, of course, we even refer to, so if we have, this is rubbing alcohol, right? Isopropanol. And then, what is the alcohol that we like to relax with on a Friday night? That's found in our beer. Ethanol. Yeah, ethanol. So I'm gonna try to make ethanol. So I actually have I'll go back to Elmo. And if we look at, for those that have your textbooks, those are textbooks. Let's write and see if we can balance some equations or reactions. I am going to turn this off. Okay, is that okay? And then raise this up. And we'll see if we can balance some equations. So let's do some I'm going to go to the quicker questions, and I think there are some practice problems and test-like questions that will show us how to balance equations. And I'll put this also in our video. Chapter 3. Where did it go? Is it somewhere here? Okay. Trigger questions. We know the answer to this. Which compound exhibits ionic and covalent? Okay, very good. D for dot, right? Sodium sulfate. Awesome. So this is like practice makes perfect, right? You want to see as many questions, test-like questions that our text throw has in this repertoire or test-like questions. Which would not be classified as a molecular compound? So CO is a molecular, right? We agree. C2H4 is, right? So is C6H12O6, that's glucose. So is NH3, but ammonium, this could be a test-like question. What's the name of NH4 C2H3O2? That's ammonium acetate.
So how would I know that?
How would you know? By looking at it's in the list of Acetate, C2H3O2, is a list of the anions.
Okay.
And NH4 is the only cation.
Right, so you said it was the only
The only polyatomic cation, awesome, Amanda. So these two are unique, right? NH4, C2H3O2. So what would be the correct formula for aluminum bromide? We know that aluminum is in the group 3, right? So therefore it would be 3 plus. So therefore we want it to react with 3 bromine atoms. Do you agree? Any questions here? Because that's really important. No questions? Yeah. Today's topic was pretty tough, right? Because too many concepts. Okay, BR. So it's in the 3rd row.
Oh,
Yeah. I know, it takes a while.
what was it the answer?
ALBR, yeah, the highlighted one. ALBR3, right? That's the answer. Since AL is 3 plus, so what would be if it was aluminum chloride, right? So it would be AlCl3. Now, if it's aluminum oxide, what would it be? So aluminum oxide, so how would we write aluminum oxide, okay? So we know aluminum is 3 plus, but oxide is 2 minus. So we write down aluminum 3 plus, and oxide is 2 minus, right? We agree? So whatever is in the superscript up here becomes the subscript in the bottom, and likewise, right? So then therefore, aluminum oxide is written as A2O3.
It's oxide because
You will say aluminum oxide, but you don't want to say aluminum trioxide because it's a metal and oxygen is an ionic, right? But if it is P2O5, what would it be? So diphosphorus and toxide, right? Because you'll be asked to name them. So you want to be able to recognize the metal, non-metal way of naming compounds, and the way to name ionic compounds. And then when you're mixing ionic compound, calcium carbonate, right, with CO3. So for this one, right, what would be the answer for FeCl3? Okay, so letter C, right? Letter C is the correct answer. So for potassium carbonate, what would it be? It would be letter, so potassium. So since carbonate is 2 minus and potassium is plus 1, so therefore we need to put 2 on the subscript of potassium. What would that be?
C.
Letter C. You see that? Right? So minus 2 plus 1, so you gotta put 2 where on the subscript of potassium. Okay, here's the picture of, so Toy used to predict weather, has a picture of cobalt 2 chloride, and here's the reversible reaction. So if you add cobalt chloride and add water to it, so you get this hydrate, cobalt 2 hexahydrate, but then when you heat it with a Bunsen burner, right, then it'll turn purple and becomes anhydrous. So anhydrous means we just mechanically remove the water out. So which statement is correct? The picture was red on sunny days or B?
B.
B, awesome. Very, very good. So which name correctly matches the formula? Why is A not right? Because it just says phosphorus. Very good. B for boy. Very good. Dihydrogen. So do you know that the name of water, right? Wow, I'm so thirsty. I need to drink some dihydrogen monoxide. And your friends will look at you, right? And normally, a lot of AP students, they like to shock their parents, with that time. But it's really just water. Okay, what's the oxy name for SO3 2 minus? So just think of water, right? Everyone gets thirsty. I got thirsty. So it would be sulfurous because SO4 is sulfate. But this time, I don't think, if I see that in the exam, I'll either make it an extra or a bonus or delete it, okay? But, okay, this is, how do you calculate the molar mass of calcium phosphate? So do it right now. Raise your hand, whoever gets it first, gets 5 points today. Come and show me, and I'll give you the 5 points. There's another class activity, extra credit point, right?